Hello my dear friends, welcome to the YouTube channel Math Skill. Let's learn mathematics together. The aim of this channel is to help students overcome the fear of math by learning the concepts clearly. In this session, let's discuss about the chapter quadratic equations, and the numerical what we are going to solve is a statement problem, and the numerical is two taps together can fill a tank in 9 by 8 hours. The tap of larger diameter takes 10 hours less than the smaller one to fill the tank separately. Find the time in which each tap can separately fill the tank. This numerical is a part of CBSE as well as NCERT for 10th standard mathematics. I am your trainer Venkatesh K. Now let us see how to solve the problem. So here he says two taps together can fill a tank in 9 by 8 hours. That is, for a tank there are two taps. One is larger diameter tap and one more is a smaller diameter tap. So also he says the tap of a larger diameter takes 10 hours less. That is, if the tank is filled by larger diameter tap alone, it is taking 10 hours less compared to the time being taken by the smaller diameter tap if only smaller diameter tap is switched on. Now based on these two conditions, we will have to find the time taken by each tap to separately fill the tank. Since the time taken by the larger diameter pipe is given in terms of the time taken by the smaller diameter one, so let us assume the time taken by the smaller diameter tap to be x, so many hours. That is, what I've done is I've assumed that the time taken by the smaller diameter tap to fill the tank separately as x hours. With this, because he is saying that the tap of a larger diameter takes 10 hours less than the smaller one, since I've assumed the smaller diameter tap to be taking x hours, therefore the time taken by the larger diameter tap would be x minus 10 hours. This is based on the statement which is given here. With this, let us now find out the amount of a tank filled by the smaller tap in 1 hour. Because we have assumed that the smaller diameter tap would take x hours to fill the tank completely, in 1 hour it would be filling 1 by x, so much amount of tank if switched on alone. Now similarly, the amount of tank filled by the larger diameter pipe tap in 1 hour would be 1 divided by x minus 10. Also, the condition what he gives as two taps together can fill a tank in 9 by 8 hours. Let's note it down. That is, if both the taps are kept open, now both will together fill the tank completely in 9 by 8 hours. Because it is a mixed fraction, let us convert it into the improper fraction. That is, 9 8 is 72 plus 3 is 75 divided by 8. That is, time taken by the two taps to fill the tank completely is equal to 75 by 8, so many hours. Since we have found out the amount of a tank filled by the smaller as well as the larger tap in 1 hour, so let us now find out if both taps are kept open. Now what is the amount of tank that will be filled in 1 hour? That is, based on given data, this is 1 divided by 75 by 8. 1 divided by p by q, because there is a fraction in the denominator, now it will get reciprocal. That is, we would be getting amount of tank filled by both taps together in 1 hour would be 8 divided by 75. Denominator would become numerator. That is, there is a reciprocal, which means it is equal to 8 divided by 75. This 8 divided by 75 is amount of tank filled by both taps together in 1 hour, which means that it is inclusive of two components. That is, amount of a tank filled by smaller tap in 1 hour, also amount of tank filled by larger diameter tap in 1 hour, both put together would be equal to 8 divided by 75. Also, we have found out tank filled by the smaller tap in 1 hour as 1 by x just now, plus similarly larger tap is 1 divided by x minus 10 is equal to 8 divided by 75. Since we have in LHS two fractions, that is p by q form, in which denominators we have variables. So in order to take LCM, let us multiply both. That is, the LCM would be x into x minus 10. Now is this x gets divided to these two. So x would get cancelled. We would be left with x minus 10. X minus 10 multiplied by 1 is x minus 10. Similarly, x minus 10 cancels x minus 10 here. We would be left with x multiplied by 1. So we would be having x here. That is, upon opening brackets, x minus 10 plus x divided by x into x minus 10 is x into x is x square minus x into 10 is 10x is equal to 8 divided by 75, or in numerator x plus x would be 2x minus 10 divided by x square minus 10 is equal to 8 by 75. Now let us do cross multiplication. Upon cross multiplication, 75 gets multiplied to 2x minus 10 and 8 gets multiplied to x square minus 10x. That is, 75 into 2x is 150x minus 75 into 10 is 750 is equal to 8 multiplied by x square is 8x square minus 8 into 10 is 80x. Now let us transpose the terms in LHS towards RHS. That is, the terms of RHS would remain as it is. On LHS I would be left with 0 is equal to 8x square minus 8x would remain as it is, whereas plus 150x would become minus 150x, minus 750 would become plus 750. Now 8x square would remain as it is in next step, whereas minus 80x and minus 150x are like terms, so they would get added and we would be getting minus 230x plus 750 as it is. Now we see that all the terms are even. That is, let us take the common factor. The common factor is 2. So I would be left with 4x square minus 115x plus 375 within bracket. So upon dividing by 2 on both LHS and also on RHS, so the 2 would get cancelled, whereas on LHS 0 divided by 2 is 0 is equal to 4x square minus 115x plus 375, or I can rewrite the terms as 4x square minus 115x plus 375 equals 0. Now this equation cannot be simplified further as it contains three unlike terms. That is, the first term is a x square term, second term is an x term, and third term is a constant term, which because they are unlike, they cannot be simplified further. Now let us compare this equation to the standard form. Ax square plus bx plus c equals 0. On comparison, we see that both the equations consist of the first term with x square, and also the second term contains x, and third term is a constant term. That is, both look similar. Because it is looking similar to the standard form, we can start the factorization. Now let us do that. In order to start factorization, let us multiply the first and the last term. That is, upon multiplication of a 4x square into 375, so we would be getting 1500 x square. That is, upon multiplication of the selected factors, we should be getting 1500 x square. Also, upon addition or subtraction, the middle term, that is minus 115x, we should get. Because the number 1500 is very big, let us do the prime factorization. So upon doing prime factorization, we see that 2 is available 2 times, 3 once, and 5 is available 3 times. That is, I have noted down the prime factors as 2 multiplied by 2 multiplied by 3 into 5 3 times. Now we will have to rearrange the terms, that is the prime factors what we have got here, to select 2 factors, so that upon addition we should be able to get 115. That is, if the factors are multiplied like this, that is 2 2s are 4 and 5 5s are 25. So 25 4s are is 100 and 5 3s are 15, that is 115. If we are selecting the prime factors, then upon addition of minus 100x and minus 15x, we would be able to get minus 115x. That is, selected factors are minus 100x and minus 15x. Also, minus 100 into minus 15, if multiplied, we would be getting plus 1500. That is, minus into minus is plus, 100 into 15 is 1500, x into x is x square. Now, both the conditions are satisfied. That is, upon multiplication, we are getting 1500x square, and addition or subtraction, we are getting minus 15 and minus 115x. Therefore, the factors can be selected here. So, with this, let us substitute that is, let us replace the middle term minus 115x with the two selected factors of minus 100x and also minus 15x. That is, minus 115x is split up into two terms, minus 100 and minus 15. Also, now let us take common between first two terms and the last two terms. That is, out of 4x square and minus 100x, we see that 4x I can take common. Here, out of minus 15x and plus 375, I can take 15 common. Now, upon taking common, 4x out of 4x square and minus 100x, I would be left with x minus 25. Also, minus 15 into x minus 25 equals 0. Now, we see that x minus 25 is common between the two terms what we have here. If you take x minus 25 as common, now we would be left with 4x in the first term and minus 15 in the second term. That is what we have got here, 4x minus 15. So, I've taken x minus 25 as common. Now, the multiplication of two terms, a into b equals 0, which means either a equal to 0 or b is equal to 0. That is, either x minus 25 equals 0 or 4x minus 15 equals 0. That is, upon transpose, that is, in order to simplify, let us open the brackets. So, x minus 25 equals 0, or the second term would be 4x minus 15 equals 0. To find the value of x, let us transpose the constants towards RHS. Upon transpose, minus 25 would become plus 25, that is, x is equal to 25, or 4x is equal to 15. Now, upon transpose of this 4 towards RHS, it will get divided to 15, that is, we are getting 15 by 4 here, which means either x is equal to 25 or x is equal to 15 by 4 or 3.75 so many hours. Since x is what? X is the time taken by the smaller tap to fill the tank. So, time taken by larger tap would be x minus 10. So, if we find the larger tap, time taken by the larger tap, considering x to be 3.75, then time taken by the larger tap would be negative, which means that x is equal to 3.75 cannot be considered. Therefore, the time taken by the smaller tap would be 25 hours. Considering this, the time taken by larger tap would be x minus 10, that is 25 minus 10, which means it is 15 hours. Therefore, to conclude the problem, time taken by the smaller tap would be 25 hours and time taken by larger tap would be 15 hours. If only larger tap is switched on, then it would take 15 hours to fill the tank. Also, similarly, if only smaller tap is switched on, it would take 25 hours to fill the tank completely. This completes the solution. Thanks for watching the video. Take care.